one of the first things we're going to talk about here is we're going to talk about units and dimensions. The reason we have to talk about this is because we're going to be trying to use numbers to describe a lot of things in this course, but the problem with just using numbers is they don't have a physical significance. So if you take a look at the number 5 here on the screen, we should probably make this a little bigger so it's less tiny and easy to see. But if you take a look at, say, the number 5, 5 by itself doesn't really mean anything. If you ask somebody to show you a 5, yeah, they can give you a high 5 or something like that. But 5 only compares things. So when you're dealing with numbers, they are always related to comparisons. For example, you can compare 5 and 4. You can tell me that 5 is greater than 4. That works perfectly well, but if you try to move them to the real world, they don't really mean much unless you are directly comparing something. So at the end of the day, we have to combine them with things that have a physical dimension. Now, most of the time, people refer to dimension as things like length, width, and height. Dimension in physics effectively refers to what physical quantity are you measuring. So, for example, if we have something like 5 inches, this is a physical quantity. An inch is something in the real world we can relate to, and the number 5 in front of it tells us that there's 5 of them. In terms of algebraic speak, the inches here works exactly like a variable does, right, like x or y, and the 5 here acts exactly as a coefficient. And that is basically the key to dealing with these types of things. Now, when it comes to working with dimensions, you don't really have to memorize too many of them. There are, however, 6 common ones that we most often look at. These 6 common ones you'll see on the screen now in a nice little chart. The idea is when we're talking about dimensions in terms of physical quantities, there's only 6 of them that we're going to look at. Of those 6, we're actually going to only look at the principal 5 that show up the most often. The 6 is a unit of brightness, which doesn't get used a lot. But basically, there are things like length, how long something is, which in the SI system is measured in the meter. There is the mass, or how hard something is to accelerate under a push, which is measured in the SI unit of a kilogram. Time, which usually needs no explanation, which is measured in the SI unit of the second. Temperature, which is measured in the SI unit of the Kelvin. And electric charge, which is measured in the SI unit of the Coulomb. And these are basically the 6 main ways in which we can describe things. Now, in terms of dealing with dimensions, the reason we talk about them is because whenever you're performing a mathematical operation, in order to do so, if we add physical dimensions into the mix, the dimensions have to match. If they don't match on both sides of an equation, or via addition, or basically anything else, whatever you're doing is wrong, like just flat out wrong. And evaluating this is a technique that's known as dimensional analysis, which we're going to spend a little bit of time looking at because it's one of the best ways to figure out if what you did is correct.